Alright, I think I gotta. Oh, I didn't finish this. Good. Good. Okay.
Storage right there.
Yeah. Why did I? Okay, I know. I know why I stopped. I, I mean, just before the stream, I did look up how I could do this. Because I was not very sure. Still, I'm not. So, if I saw one of this example here from Cloud, and uses multiple arena allocators. Kinda makes sense. Just want to check something. Will he switch to... I'm guessing at some point he'll use one of the memories, like the permanent or transient, to... What's it called? I can't remember now. Yeah, for audio, sorry, sound or the frame buffer. My guess. I think it's pretty valid guess. 'Cause something I gotta check in the documentation. How much memory is sort of allowed? Max memory. It was not out of memory, I think. Segmentation fault. Whoa. Why did that work? That was not supposed to work. At least it didn't the last time. Let me. Where's the documentation? Here. Choosing an allocator. Making a library, no. Linking libc, no. Need to use the same allocator, not really. Is your program a command line application which runs from start to end without any fundamental cyclical patterns such as video game main loop or a web server request handler? Maybe not. Okay, I mean, this one clearly makes sense. Are the allocations part of a cyclical pattern such as video game main loop or a web server request handler? The allocations can be freed all at once. At the end of the cycle, for example, once the video game has been fully rendered, I don't want to like free it after every frame. Seems kind of wasteful. So allows you to free entire arenas at once. Note that also if the upper bound of memory can be established. Yeah, then fixed buffer allocator makes sense. I think there is. Where do I use reset? Here. So when I resize memory, how does the fixed buffer allocator work? Okay, so you don't really need to free anything, which is good. I think the question that I have is, what if I wanted to, let's say, resize the memory, like here. But I think at some point this is going to be removed, so I shouldn't really have to worry about that. I guess it does work. I don't know why it didn't work last time. And also I just realized, do I need to be able to make a separation between permanent memory and transient memory? Okay, it's been a couple of days, so I don't really remember. I'm gonna go back a little bit and try and watch again.
The first reason is because you got to have a strategy for the failure cases, right? Either you're gonna have to handle it somehow. One way is basically you just say, all right, everywhere that we do a new or an alloc, we check for failure and we actually handle the failure propagating all the way out. That's difficult, right? That is tricky in a lot of cases because now you got all these paths that can both fail and succeed, and you got to know how each of them works. What happens if I didn't get a game asset and I needed to in this case? What happens if this particular system couldn't start up because of memory? Whatever. Do I panic? What do I do there? But you got to have a story. Another story might be, oh, well, we ran the game lots of times and we looked at how much it used, and we always make sure we get that much on startup, and then we use our own allocator that sub-allocates out of there, and we just know from having ran it multiple times that we know that it just doesn't overrun this much memory. We hope, and we just hope the player doesn't do something that we didn't think of. Who knows? But you gotta have a story. There's some story. Sometimes the story, and there's plenty of games that ship, and this is the story. The story is we have no idea. The story is just we just don't know. It doesn't seem to run out of memory when we've tested it, so that's all we've got. And those are all not my favorite answers, so I don't really love that. That's one downside. But there's another downside that even people who think that I'm crazy about memory might agree with in a separate context. It has nothing to do with that at all. And basically what that is it adds another loop back to your platform abstraction. And one of the things that I was talking about before is like one of the reasons that I like doing the platform abstraction this way, and like I said, almost nobody does it this way, but basically the way where it's two data pipes in and out, and you're trying to basically minimize the cases where you ever do a round trip through the game. You pretty much just want the game to be a service to the platform, where the platform just says, I need the video frame, I need the audio. That's like what you're looking for, and it pushes down the input to it. Just says, here's the input. So there isn't like any time when the platform calls the game calls the platform again, just to completely get rid of that round tripping. Because again, that round tripping is what creates complexity in terms of understanding how the platform and the game layer relate to each other, and it means that if you want to do some more advanced things, like say recording the entire session of a game and playing it back for debugging purposes, if you know that you have one defined input stream and one defined output stream kind of a thing, it's a lot easier to do that sort of thing, right? And so unfortunately, that argument is a lot weaker these days now that multi-core is such a thing. It becomes extremely difficult to do playback systems properly because of all the threading stuff, so it's the least of your worries, the thing I just said about. But in the old days when things were single-threaded, this was definitely a huge win in terms of playback. Not so much anymore, because you got a lot of other headaches you got to worry about in that situation. So, what's the alternative to this? What do I propose if I don't think this is a good idea? Well, what I'm going to do instead is I'm going to do exactly the same tack I took before and just say, well, if the game wants memory, then the game gets memory from the platform layer in a big old chunk at startup, and the game is responsible for doing everything else, right? Basically, I'm just going to say, you know what? We just pass in a big old thing here called game memory, and that's just a struct, right? And that struct is going to have basically stuff in it that allows us to allocate what we need, do our partitioning on the game side, and then all that's going to happen is the platform layer is going to call one, or it can call as many as it wants really, virtual allocs at startup to get our memory space set up, and then once it is set up, that's it. It just gets passed to the game. The game is responsible for sub-partitioning that memory, and it is responsible for ensuring that all of its systems always operate inside a fixed space, so they can be pre-partitioned at startup, and you know that if the game started up at all, it will run to completion, period. And we'll be also seeing that I will take the same tack with disk I/O, which I realize is a little odd, but I'll be taking the same tack with disk I/O. So the goal here is like there's 0 failure states in the game. The platform layer obviously can have all kinds of failure states because the operating system is not built with a similar philosophy. The operating system is built poorly. It is Windows. It does not do a good job on any of the fronts that I'm talking about. And so once we get down to the platform layer, we can't create something that is reliable. That's true. But we certainly can create the game in such a way that it is 100% reliable, and that is what we will be striving for. We will definitely be looking as we go to hitting the highest benchmark we can in terms of making the game so that once it starts up, it does not fail. And if things like disk I/O fails, that just means there's sprites missing, but the game works, right? That's sort of what we're going for. And we'll sort of have a like gold, silver, bronze standard there, and we'll see kind of how high we can hit depending on the circumstance. Different games can hit that standard at different levels depending on what they need to do. Basically, it has to do with space, but we'll get into that later. All right. Anyway, so basically all I want to do is I want to pass memory here, and I'm going to say a couple things about my memory. Basically what I want to do is I want to sort of subdivide this memory into a few different partitions. Basically, I want to have scratch space, sort of space that is not really about storing the game, and then in theory could kind of go away at any given time. So it's kind of like space that is transient, and then permanent stuff. So basically, stuff that stores the actual state of the game, such that it definitely needs to persist as is from one frame to the next, because it's what holds sort of the game together, right? And so basically, what'll happen here is I want to be able to store these things: the blue offset, the tone hertz, the green offset. Those are examples, right, of things that need to be stored in the permanent store. And so that's really all I have right now. And so basically what I've got is I've got an I guess I'm going to use an N64 here in case we ever want to be absolutely giant. So I'm going to say we have a UN64, which is essentially our permanent storage space, and then we've got a void star, which is our permanent storage, right? So all I'm doing here is I'm basically saying, well, I'm going to have some place to store. Wow, I'm a spelling genius tonight. Basically, I'm going to have some place to store things that have to persist from frame to frame, because that's what I want here. So all I'm going to do is I'm going to basically say, well, that game state thing that I had, right, that I defined before. Oh, did I just go ahead and delete that? I'm an idiot. That's not good at all. I wanted to keep that. I just wanted to move it. I didn't want to delete it. There we go. So anyway, let's get that back there. Game memory. There we are. So basically what I want to do is I'm going to take this game state here, right, and I'm just going to put that inside the game memory. Now I can put that here. I don't know if this doesn't really need to be in the stuff that defines the platform, so I'm just going to separate that out for now. We'll see where I want to live later, because this is not something that the Win32 layer needs to know about. So I'll think about it a little differently. But point being, this guy is going to come in here, and basically all I'm going to do is I'm going to say that my game state, right, whatever this game state is, that's just going to equal, for now, I'm just going to go ahead and cold cast straight to the actual memory that I've got for my permanent store, right? My permanent storage right there. And then what I'm going to do is I'm going to basically
What is that? Game state. Okay, so whatever's in permanent memory is game state, basically. Okay.
my permanent storage right there. And then what I'm going to do is I'm going to basically introduce a notion here. And that notion is essentially that the game memory will have some concept of whether or not this is the first time around. Because obviously there's initialization that has to be done, that initialization that was going to have a call before that did the round trip alloc. I still want to do the initialization. I just don't want the round tripping. So I'm going to say for now, I'm going to say is initialized, and basically that's going to be false the first time through and true every time thereafter. So basically what I'm going to do here is I'm going to say if the memory is initialized, I should say if not, then I am going to go ahead and initialize it. I'm going to go ahead here and say that the game state tone hertz are 256, and then the other guys, let's see, green offset equals 0, game state blue offset equals 0, and that's really all I needed to do, right? So now we've gotten rid of our local persist, and those are in there. So now all I need to do is I actually need to pass this this memory out to the game. So I'm going to call that game memory. I'm going to go ahead and say game memory, and then I've got to actually do those allocations here to actually get it something that it can use. So where's my virtual alloc?
Okay, I'm gonna try and get to that point. Where is my game memory? Here. Is that how you spell that? Transient. Maybe. But I don't use this at this point. Let's get rid of that for now. Or maybe I can use it. I don't know. Is initialized. Function actually no. It needs to be public. Should I just call this memory? Okay, memory is fine. And where is game update and render? Does it need to pass game state as well? It doesn't. Memory is going to be game memory. Pointer to game state is pointer past game memory. No longer needed, I guess. Yep, because it's going to be assigned. If not game memory. Dot initial. How do you spell initialized? Okay, yeah, I was right. Initialized. Yeah, a couple of questions there. They're going to cost it. Oh, this is wrong. This should be game memory dot permanent memory. That's a typo. Permanent. Jeez, my spellings are like okay. Yeah, it looks right. Oh, it's permanent storage. Excuse me. Right. Okay. Game state dot tone hertz. It's 256. Okay, I think that looks fine. And then it's just the allocations, which I want to see how he does it first.
Analog. I've got it in here somewhere. There's for the there we go. There's the one for sound. So I'm going to still do separate virtual Alex for now, even though in the future we may well pool those guys together because that's something I wanted to do. All right. So the game memory, I'm going to wipe that to 0 first. Then I'm going to say the permanent storage size. I don't know how big the permanent storage size for our game is. These are going to be constants we're going to tune, but I'm going to say something like 64 megabytes maybe. I don't know. Let's pretend that it's going to be 64 megabytes. Just for now. We'll see how much we actually need later. And then I'm going to say that the permanent storage, right, like this, is going to equal another one of these nice virtual Alex here. And that's going to be...
Oh, okay, hang on. I think I just realized how it can be done. In Zig, maybe. Memory dot. Oh, okay. I see why it worked because I only allocated 4 MB. So the 64 MB. If I do plus 64 MB, and this becomes I think this won't work. What is align cast? Changes the alignment of a pointer. The alignment to use is inferred based on the result type. Cannot implicitly convert slice to a single pointer. So I gotta do point align cast. Yep. It's initialized. Transitive failure. I mean, that's not very useful. I think I know what's happening. Permanent storage size. Transient storage. SIENT. Okay, size. Permanent storage. Initialized. Then permanent. Creator doc create. Type. Yep. Type and size. Permanent storage. Then this expected type slice of U8, but found slice of oh yeah. Let's see. U8. I mean, I don't think it's gonna work. Const. Expected type pointer to handmade game memory found const pointer. And I can either do a const cast. It is a const. It's equal to allocated or create. Catch and reach table. Then get rid of this, get rid of that. Then I should get rid of that error. Game memory. Yep. So kind of low. What if I make it? What's the lowest I can go? Still no. What about 100? Damn. Transitive failure, so I think it's something else. Attempt to unwrap error out of memory. Yes, Cloud. What is the upper limit for a fixed zig? Get a transitive error when I try. I use and no. Okay, so I think the general purpose allocator seems to be the way to go. What's the equivalent of? I got one more question. Is there an equivalent? See virtual alloc in Zig. Interesting. Standard amount of page size. Okay. I had no idea about page allocator. Directly to every allocation. Free. Get rid of these. Keep that page allocator. Okay, so it returns the allocator interface. How will that work? I think you go to init. I guess might as well then use the arena allocator. Seems simple enough. right out of memory. Okay, no, it didn't. It's the cast. Actually, it just makes it seems easier to just store the game state as is. What if I got rid of this for now? Then, excuse me. Change this to game state. Pointer to game state. Go to this. What if I wanted? Let's try a GB. Oh, hang on. Where is? No, game memory dot is initialized. Why is that a problem? Implementation fault at address here. Oh, hang on. Just realized. Oh no, I do. I thought it was. That's weird. Implementation fault at address there. Game memory dot is initialized. I have no idea. What is the type? It's pointed to a game memory. Okay, so as soon as it renders the first frame, that just doesn't make any sense. It's the same address every time too. Or it looks the same. It's called 152. Somehow this memory is not available here. That's weird. What if I made this global as well? Memory is going to be handmade.game memory. I think I just realized what was wrong. No, I don't. No, that's not it. I guess I can just remove that. Why does that fail? That is weird. I'd like to understand why. Let me look at one of my other projects. Okay, to the gate. Let me try the same then. Good star. Dot game state dot star. What do you mean it's never mutated? It's mutated right here. But set. Yeah, it failed that again. Right, let me ask. Why does this happen? I don't like that it's a const pointer. I need it to be mutable. Being a broke cloud segmentation fault. Hang on. Really? No. I don't think that's it. That's my... Yeah, it's within the game though. Well, the only thing I can think of is that this is too big. Let me just make this something smaller. Don't like that it complains. No, so that's not it either. I don't know. Totally stuck. Hang on. The sound does play millisecond per frame. So it's able to render it the first time. So that means this gets initialized once. Second time doesn't work. I wonder if that makes a difference. Not really. I have no idea why that's happening. Oh yeah, sorry. Where did that come from? Fuck. I think I just broke. I don't know what I did, but damn. So somehow, okay, something's very wrong. I can read it the first time, but excuse me. And the second time, no. That is so weird. Mm. I mean, it doesn't need to be global. I think what I want to check is off. No. The only thing I can think of is here. Okay, so that was it. That means if I try to, yep, resize won't work. But that's good though. At least I know what's happening. All. Can I do retain capacity? Oh, but I can't. Can't reset everything because I need the game state. Yep. Okay, that's good. I'll handle that in a bit. Or I could just clean this up, I guess. Got the daily spam. Okay, this is not needed because it'll be false anyways. I think also not needed. Okay, now I want to try if I can do 1 GB. I guess I need all of it. Is initialized. Get rid of that. Don't need that. I do need to move sound to a different thread. It's quite annoying. But at least it works. I guess the next step would be to move get memory size. How much did I allocate? Was that a GB? No, it wasn't. Okay. That's good to know. Why 0 frame per second? Oh, because, okay, I get it. Because there's no frame rendered. Because sound blocks. Yeah, it's fine. Can I just turn off audio for a while? Why does it try to play audio? That's weird. Oh, okay, I see why. That makes sense, because it's in the platform layer. Okay. That looks better. Now, I think what I want to do is... Well, I guess I can keep watching for now. Move ahead.
However much I just said the storage size was. So there it is. We're going to mem commit that because we're going to use it. And then all I'm going to do is I'm going to go up in here into this guy, and I'm going to define a couple more macros for me here. These are ones I just like to hold around, basically kilobytes. Is. So I'm going to basically say we're going to...
Okay, I think I watched the rest of it. I'm curious as to why. I thought he would move the sound and video buffer to transient memory. Maybe he wants to do it later, but I could do it now. What is sound buffer size? Sample rate times channels. Okay. So what I can do is grab this, move that down. Instead of allocating, so just be game memory dot transient storage. Okay. And then this would be step 0. This would be buffer dot get buffer size. Guess that makes sense. And then resize. I can retain capacity. Oh no, don't need to reset it anymore. Some buffer will stay the same. I think don't need this either. Buffer dot memory will be, excuse me, yep. Right. Pointer to handmade game memory. Off-screen buffer. Yep. Okay. It's a slice of I16. Well, that's a good point. mm. Not sure how I know how to do that yet. Mhm. That is a good point. Let me check documentation. Cool. Glass cloud. Can I? Should have mentioned Zig. Okay. Bites a slice. Given a slice of bytes, returns a slice of the specified type backed by those bytes, preserving pointer attributes. What type is the sound buffer? Transient storage. Okay, it's also an i16. Need type and bytes of any type. So byte is slice of U8. U16 bytes 02. Ah, interesting. I've got to know. Hang on, since both of them are i16. No, it's U32. Okay. That's not gonna work either, so. I mean, the sound buffer size is always fixed. It's not gonna change. Okay, so have a single large slice of U8. How can I know when slice of ice where? Typing's gotten worse. Oh, okay. I see. That makes sense. Yeah. I can use memdub bytes as slice. Type and bytes. By 16, and then game memory. What is it actually doing? Copy pointer attributes. Okay, so because really all it needs to do is know where it starts and where it ends. Info is pointer info. What do you do with the source? Okay, I see. You get pointer info from source. Kinda. I don't really get it. This will be the same memdub bytes as slice u32. Game memory transient storage. Global buffer, buffer the length times by 16. I mean, it looks okay to me. Slice of alignment of 1. Can I? Pointer type slicer U32 cannot be a kind of cast into pointer type child. Okay, there's a couple of mistakes there. This U32. Then align cast. Oh, because it gets cast to a slice of. No. Something's wrong. Yeah, something is definitely wrong here. I'm not sure what. See it again. Oh, okay, I see. It's a different. It's the resize. Okay, that's good. Okay. That doesn't work. It has no length. To do both buffers do no work. I gotta figure that out. I haven't done that ever. But it kind of makes sense. Switch to game memory. I mean, I could leave it empty for now. Guess let me just go back. Undo. Leave that there. I mean, at least I know I can get a GB of storage. Okay, that's fine. And I'll leave that. Fine. Looks the other one looks too weird. Locate GB of transient memory and set up game memory. I mean, technically, it should be possible to write to a slice of U8 because they're all just bytes at the end of the day. I think I'll solve that problem later when we get to it. So I guess we could start day 15 tomorrow. Alright, I think that's pretty good. Good enough. What is day 6? Visual Studio compiler switches. Okay. I'm gonna call it a day there. Yep, have a good weekend. And shall see you back here tomorrow. Yeah, well, actually, one more thing. I don't know if I didn't know if I want to talk about this, but it has gotten like hard to stream. I'd say this week and the week before, I'd say. I mean, yeah, and not really hard. The thing is, for the first time yesterday, I was like, do I even want to stream? I do, but I found myself unmotivated to stream for the first time since I started streaming. And I realized that, I mean, I can either keep going or not. I do want to keep going, but I realized my past self would have definitely quit by now, or like at that moment. And I don't want to, because I want to see where it goes a year from now, or like 2 years from now. and I want to know that I can follow through with something for a long time. So I'm gonna continue streaming. The next few weeks are not gonna be great in terms of stream because I'm gonna be like dragging my feet. Maybe, I don't know. Once I start streaming, it's actually a lot easier. So, yeah, I don't know what the point is, but well, okay, yeah, actually, the point is that I mean, these moments, or like these moments define, or how you react to these moments define how long you're able to do something. And I think it mostly comes to expectations. For some reason, I thought, oh, it wouldn't matter how many people show up or not. It kind of does. But you gotta find a way to work past it. As to why. I don't know why. I mean, for me, the why is that I tend to. What's the word? Yeah, I tend to follow through on my side projects a lot better when I'm streaming. So that should be the one and only goal. And I've got to learn to disassociate with the other aspects, sort of take over in subtle ways. I don't know. I just wanted to. It was something I was thinking about yesterday and today. And I do want to like show up more consistently, regardless of the outcome. Because I think in the long term that matters more. And the outcome will get better. The longer you do it, it only gets better. And at the moment I suck, I know. But yeah, I guess that's it. I don't know why it's not like me to talk about this stuff on stream, especially. I mind talking to people. But yeah, okay, but that's it. The final the final take is that I mean 6 months down the line when you feel like quitting, just try and go for 6 more months or one more day. You never know. You never know. Alright, you have a good day if you're watching or listening to this. And I shall see you back here tomorrow. See ya. Have a good one.